Hey everyone, welcome to this quick lesson on p-block elements. Ever wondered where fertilizer get their power? It's largely thanks to p-block elements like nitrogen and phosphorus. Let's dive in. So, what exactly are p-block elements? They're the elements in the periodic table's groups 13 to 18, where the last electron enters the p orbital. These elements are super important for ICSE because they show up frequently in reactions and have diverse properties. You'll definitely see questions on them. Let's start with the general trends in the p-block. As we move down a group, atomic size increases because we are adding more electron shells. Ionization energy, the energy needed to remove an electron, decreases as the outermost electrons are farther from the nucleus. Electronegativity, the ability to attract electrons, also generally decreases down the group. Now, a key definition: ionization energy is the energy required to remove an electron from an isolated gaseous atom. It tells us how easily an atom loses an electron. Next, let's talk about group 15 elements, also known as the nitrogen family. Nitrogen is a gas, but other members like phosphorus, arsenic, antimony, and bismuth are solids. They show a variety of oxidation states, mostly +3 and +5. Nitrogen also forms multiple bonds due to its small size and high electronegativity. Here's an important formula: oxidation state, the charge an atom would have if all bonds were ionic. Remember, it helps predict how elements will react. Now, let's look at group 16, the oxygen family. Oxygen is a gas, while sulfur, selenium, tellurium, and polonium are solids. They're known as chalcogens because many ore deposits contain oxygen or sulfur. They show oxidation states of -2, +2, +4, and +6. Another key rule: electronegativity decreases down the group. This means oxygen is the most electronegative element in the group. Remember this. A common mistake is forgetting the inert pair effect. As you go down the p-block, the tendency of the s electrons to participate in bonding decreases. This affects stability of lower oxidation states. Let's try a quick problem. Q. Explain why nitrogen does not form pentahalides while phosphorus does. Uns. Nitrogen lacks d orbitals to expand its octet, whereas phosphorus has available d orbitals. This allows phosphorus to accommodate more atoms and form pentahalides. Here's a real-world application. Ammonia, made from nitrogen, is used in fertilizer. Fertilizer provide essential nutrients like nitrogen to plants, promoting their growth. This is directly related to topics you learn in the ICSE syllabus about chemical reactions and industrial processes. Exam tip: always pay attention to exceptions to general trends. Examiners love to test these. Also, practice writing balanced chemical equations involving p-block elements. Finally, remember the uses of important compounds like ammonia and sulfuric acid. To recap, we covered general trends in the p-block, focusing on atomic size, ionization energy, and electronegativity. Then, we looked at the properties of group 15 and group 16 elements, including their oxidation states and bonding characteristics. We also saw how p-block elements are used in fertilizer. All of this, AI notes, doubt solving, practice tests for p-block elements, is free on Synapse. Study smarter, not harder. Start free today at synapse.omups.in. Master p-block elements for ICSE. Please subscribe to our channel for more free lessons. Visit synapse.omups.in and start learning today.